Hello everyone. In this video I'm going to be solving this pure mathematics paper 1 from October-November 2024. And for the first question, we're given a diagram, and the question is saying the diagram shows the curve with the equation y equals a sine bx plus c for x taking values from 0 to 2 pi, where a, b and c are positive constants, meaning a, b and c are positive numbers. And part A is saying state the values of a, b and c. And so to get our a, b and c, we're going to consider the graph of sine x, which I'm going to try and sketch. Passes through the origin, half pi, then 3 over 2 pi, and lastly 2 pi, like this. So it looks like this. Now we're having this graph of sine x being multiplied by a, and x being stretched by a factor b, and having a vertical translation in the y-axis of c units. And for us to get that, we're going to try and work from the inside going out. So we're going to start with b, followed by a, then lastly c. And to do that, we're just going to compare common points. So if we look at this part, is now here, and this part right here, it's now here. So that tells us that the x-axis has been divided by 2. If you look closely here, the x-axis for that point is now, for the x-coordinate for that point is now at 1/4 pi, and originally it was at half pi, meaning the x-axis has been divided by 2. Even for this one, it was here and now it's here, meaning the x-axis has been divided by 2. And for that, we can safely state that our b is 2, because remember, if we write it as sine bx, it means we're dividing the x-axis by this number that's multiplying x. So us saying b equals 2 means we are dividing the x-axis by 2. Therefore our b is equal to 2, like that. And for part A, we're just going to consider the y-axis. And looking at it, at our original graph, it was going from -1 to 1. So this was 1, 2 units, like that. But if you look at this graph that we have now, it's going from -1 through to 7, and that gives us 8 units, like that, from having 2 originally, right? And so we're just going to divide this 8 by this 2 to get a stretch of factor 4 in the y-axis, which again tells us that our a is equal to 4. Right? Then lastly, for c, we can see that if we are to multiply the y-axis by 4, we're now sure that a is 4. So multiplying the original y values, which are 1 and -1, by 4, it will go up to 4 and down to -4 first. Then we will need c to go from -4 to now -1, and from 4 to 7. And you can see that it is just 3 units. that we're moving up from -4 to -1 and from 4 to 7, meaning our C is 3 units. We're moving 3 units up. And so our A is 4 like that, our B is 2, we're dividing the x-axis by 2, and our C is 3, which is a vertical translation in the y-axis. And you get your 3 marks for that. And for part B, says for these values of A, B, and C, determine the number of solutions in the interval from 0 through to 2 pi for each of the following equations. And we're given A sine bx plus C, which is the one we're dealing with, and part A being equal to 7 minus x. So it's good to understand that the graph that we have on the diagram there is y is equal to A sine bx plus C. And so if we have a graph being equal to this, it means y equals this is meeting y equals 7 minus x. And this is a straight line. If we write it in the form y equals mx plus c, it will be y is equal to minus x plus 7. And with this, we have our y-intercept at 7. So we can just plot it here, 0, 7. Then to get the point at which that line crosses the x-axis, we know y will be 0. So it's x being equal to 7. And x equal to 7 is, let me confirm, 2 pi is 6,28. So x being equal to 7 is probably somewhere around here. So our line is passing through these points like this, and we can see that we have 1, 2, 3, 4, and 5. We have 5 solutions. This line meets this curve at 5 points, so we can say 5 is our answer. We have 5 solutions. And for this one, I'm saying when y equals this means y equals this. So y equals 2 pi x, let me just expand it, x minus 2 pi. We can see our y-intercept is at minus 2 pi, which is minus 6,28, which will be somewhere down here. If we extend this line to minus 6,28, it will be somewhere down here like this. And for the point at which this line crosses the x-axis, we know y will be 0. So we'll be saying 2 pi is equal to 2 pi x, and this will give us x to be equal to 1. And you know that line crosses the x-axis at x equal 1, which is half pi is 1,57. So 1 is somewhere here, and if we join the 2 points, we can see that line cuts through the curve at only 1 point. Therefore, we write only one solution for the second part of that. And for the second question, it says the first term of an arithmetic progression is minus 20, meaning our a is equal to minus 20, and the common difference is 5. Our d is equal to 5. Then part A says find the sum of the first 20 terms of the progression. So sum of n terms is n over 2 bracket or 2a plus n minus 1 d, like this. And our n is 20, so we're going to go ahead and say 20 over 2, 2a, that's minus 40, plus n minus 1, 20 minus 1, that's 19, d is 5, and that should give us 10 minus 40 plus 19 times 5. That is giving us 550, and that's the sum for the first 20 terms. You get your 2 marks for that. Then it says it is given that the sum of the first 2k terms is 10 times the sum of the first k terms, and B is saying find the value of k. Using the same formula that we used in part A, just this one, we would then be saying for the first 2k terms our n is equal to 2k, and for the first k terms our n is equal to k, and we know our a is minus 20 and our d is 5. So plugging these in to the formula there, we get 2k over 2, then our 2a, this is just k, our 2a is 2 times this, which is minus 40, then our n minus 1, saying it's our 2k minus 1, and it's multiplying d there, which is 5, in a close bracket, and this will give us k minus 40 plus 10k minus 5. This will give us minus 45k plus 10k squared for the sum of the first 2k terms. And for the sum of the first k terms, we're going to say k over 2, then our minus 40, which is 2a, plus k minus 1, or d, which is 5, like this. It's going to give us k over 2 minus 40 plus 5k minus 5. And this again will give, and simplifying this, we get k over 2 minus 45 plus 5k, like this. So we have minus 45k over 2 plus 5 over 2k squared. So now with this, I'm going to say, since the question said the sum of the first 2k terms is 10 times the sum of the first k terms, we're going to say minus 45k plus 10k squared, which is the sum of the first 2k terms, is 10 times the sum of the first k terms, which is minus 45k over 2 plus, let's just write that as 2,5k squared. And I'm gonna need space. And this gives us minus 45k plus 10k squared being equal to, we have 5 there times 45, 5 times 45, we get minus 225k plus 25k squared. Now taking everything to the right hand side, we get 15k squared, then minus 225 plus 45, which is minus 180k, is equal to 0. And from this point now, we just factor out k to get 15k minus 180 is equal to 0. So at this point, we just say k is equal to 0, or this bracket is equal to 0. So k is equal to 0, or 15k minus 180 is equal to 0, which gives us k to be 180 over 15, which is 180 divided by 15, which is 12. So you can see it said find the value of k, and we have 0 and 12. We cannot take 0 because if we take it, this will be 0, this will be 0, this and this, so everything will be equal to 0. So we're only going to take our k to be 12 for those 3 marks D. And for number 3, it's saying the equation of a curve is y equals 2x squared minus 3, and 2 points A and B with x coordinates 2 and 2 plus h respectively lie on the curve. And part A is saying find and simplify an expression for the gradient of the chord AB in terms of h. And so we know that gradient, which we can say it's m, is equal to y2 minus y1 over x2 minus x1. And so this is telling us that we need 2 coordinates, which we can name x1, y1, and x2, y2. Now to get these coordinates, we're going to use these x coordinates we have. So this is going to be our x1 and this is going to be our x2, and to get the corresponding y coordinates, we're just going to substitute these given x coordinates into the equation of the curve. And substituting 2 there, it's 2 times 4, which is 8 minus 3, which is 5. So we have 2, 5 for this one. And for the other one, substituting it there, is 2 plus h squared minus 3. And we're going to take it as it is to be our y coordinate, our y2. So now substituting into this, we get our y2, which is 2 plus h squared minus 3 minus our y1, which is 5, over our x2, which is 2 plus h minus 2 plus h minus 2, like this. And we're going to say 2 plus h squared minus, this is going to give us minus 8. And as you can see, this 2 will cancel out with this one, so we have that over h. We're going to try and simplify the numerator. So we have 2 multiplying 4 plus 4h plus h squared, like this, and we're subtracting 8. So that is going to give us 8 plus 8h plus 2h squared minus 8, and this will cancel out with this. So we're now left with 8h plus 2h squared for the numerator and h for the denominator. And factoring out h on the numerator, get h, 8 plus 2h over h, and these will cancel out like that, and we'll be left with 8 plus 2h, like that. And that will be our simplified expression for the gradient of the chord AB for 3 marks. And B is saying explain how the gradient of the curve at the point A can be deducted. Explain how the gradient of the curve at the point A can be deduced from the answer to part A and state the value of this gradient. And looking at these coordinates here, we are going to try and imagine having a chord that is small like this, where you have your A and B this close. So if our coordinate is small, we have to assume that h is approaching 0. Since our x1 is 2 for this, if this 2 plus h is close to this 2, it means h is approaching 0. When h is 0, it's at 2, and when h is slightly above 0, we get 2 plus h. So we'll be saying our h is approaching 0, and if our h is approaching 0, we can substitute it for 0 in this case. So 8 plus 2, 0, will get the gradient to be 8. So then we'll write that assuming that the chord is short and the points A and B are close together, h approaches 0, and therefore substituting h with 0 there, we get the gradient to be 8, and you get your 2 marks for saying that. And for the fourth question here, saying find the term independent of x in the expansion of each of the following. And part A, we have x plus 3 over x squared to the power 6. So the term independent of x is the term with x to the power 0. So what we're going to try and do here is to find a number that we can choose from 6 that gives us, and we're going to say, after we get the number, we will know for sure that it gives us a term in x squared. And by that I mean, if we say our number is n, say 6, choose n like this, then we start with the fraction. So 3 over, let me just write it as 3x to the power minus 2, then our x. So this will be to the power n, and this will be to the power 6 minus n. Now with these, we're going to say the total of our powers of x should be 0 for the term independent of x. And therefore, for this one, the power is minus 2n, and for this one is 6 minus n. So we're going to say minus 2n plus 6 minus n should be equal to 0. And this is going to give us minus 3n plus 6 equals 0, and our n is going to be 2. Now we know the number to choose from 6 to get a term independent of x. So we're going to say 6, choose 2, then our 3x to the power minus 2 to the power 2, then our x to the power 6 minus 2, which is 4. So 6 choose 2, it's 15 times 3 squared, that's our 9. So we get 135. And if we want to show how we get x to the power 0, this will be x to the power 4 according to this, and this is x to the power 4 in the numerator, and the 2 will cancel out. So the term independent of x is 135. And for this one, to get a term independent of x, we consider the expansion of this. So for us to get a term independent of x, or a term without x, this is to multiply a term in x to the power minus 3, so that it's x to the power 3 cancels out with this one to get a term independent of x, and minus 5 has to be multiplied by the term independent of x for this part, which we got from part A there. So first we're going to get a term in x to the power minus 3 for this, which we know that when it's multiplied by this, it will give us a term independent of x. And for the other part, we're going to say this multiplied by the term independent of x from part A, and adding those two should give us the resulting term for this whole thing, which is independent of x. So to get a term in x to the power 3 for this, we're going to go back and use this to say, if we don't know the number to choose from 6, but to get it, we can say that minus 2n plus 6 minus n is now equal to minus 3, because we're looking for a term in x to the power minus 3. So minus 3n should give us minus 9, and n is 3. So we now know that if we choose 3, for that we get a term in x to the power 3. So that's our 6, choose 3. Then we start with the fraction 3x to the power minus 2. Then this is to the power 3, and our x is to the power 6 minus 3, which is also 3. And 6 choose 3. 6 choose 3. It's giving us 20 times 3 to the power 3. Get 540. So getting 540. Then this will be x to the power minus 6 times x to the power 3. And we just add the two powers, so it will be 540 x to the power minus 3. And we know if this gets multiplied by 4x to the power 3, 4x to the power 3 like this, these two will cancel out. So 4 times that, we get 2160. And to this, we're going to add the term independent of x that we get from multiplying minus 5 and the term independent of x for that other part. So minus 5 times 135, we get minus 675. So adding the two, we have something like this. So 2160, like that, we get 1485 as the term independent of x for part B. And you get 4 marks. And for number 5, says the function f is defined by f of x being equal to 2x plus 1 over 2x minus 1 for x being less than half. And part A is saying state the value of f minus 1, meaning you're just going to substitute x with minus 1 here. So it's 2 minus 1 plus 1 over 2 minus 1 minus 1. So minus 2 plus 1, that's minus 1. The minus 2 minus 1, that's minus 3. So we get a third as our answer for 1 mark. And for the second part, it says the diagram shows the graph of y equals f of x, and says sketch the graph of its inverse on this diagram and show any relevant mirror lines. So we need to remember that the graph of an inverse is a reflection of the graph of the original function in the line y equals x, meaning the line y equals x is our mirror line. And now y equals x passes through the origin like this. Like that. And that's our mirror line, y equals x. So now reflecting that in that mirror line, we want to get the same distance from the mirror line. For example, if we were to reflect this part, I'm going to move the same distance, this distance, on the other side. So it will be somewhere here. So now reflecting it, we get this, that, and that will be our reflection, which is our inverse graph being reflected in the line y equals x for 2 marks. And part 3 is saying find an expression for the inverse of x and state the domain of the inverse function. And to find the inverse, we are going to take 2x plus 1, 2x minus 1. We're going to say our y is equal to 2x plus 1, 2x minus 1. And we're going to swap the x for y and the y for x. So this will be x is equal to 2y plus 1 over 2y minus 1. And we're going to try to make this new y the subject. So x 2y minus 1 cross multiply is equal to 2y plus 1. And 2xy minus x is equal to 2y plus 1. So 2xy minus 2y is equal to x plus 1. Factoring out the y, you get 2x minus 2 being equal to x plus 1. Dividing both sides by this bracket, we get our y to be x plus 1 over 2x minus 2. And this will be the expression for the inverse. So you can just write the inverse of f of x is equal to that. And for the domain, we know that the range of the original function is the same as the domain of its inverse. And so for that, we're going to say, since we are told up here that the domain of f of x is x being less than half, to get the range of f of x, we're just going to substitute values that are less than half into f of x so that we get its range. Because like I said, the range of f of x is the domain of its inverse. So if we substitute half as it is there, here we'll get 1. And 1 minus 1, you get 0. And that won't do us any good. So we're going to start by substituting values from 0,49 going downwards. So substituting that, we get 2 0,49 plus 1 over 2 0,49 minus 1. And that gives us 2 0,49 plus 1 over 2 0,49 minus 1. We are getting minus 99. Now we're going to take another value which is furthest from this, or which is far from this one, but within this, x being less than half. So let's take a negative. You can take minus 500, for example. So you're just going to substitute it in there. So now it will be 2 bracket 500 minus 500 of 2 minus 500, and we're getting 0,99800, and it's recurring. And you can see that for all the values that we're going to input into f of x that are within this domain, we're going to get values that do not get to 1. They are approaching 1, but they do not get to 1. So we can say our f of x will always be less than 1. So this is the range of f of x. And this being the range of f of x also tells us that it's the domain of its inverse. So the domain of this inverse will be x less than 1. Like this for 4 marks. And for part B, the function g is defined by g of x being equal to 3x plus 2, for x being an element of a set of real numbers. And B says solve the equation of f of x is equal to gf quarter. So we are going to start by simplifying this first. F of a quarter, we have 2x plus 1, 2x minus 1 for f of x, right? So if we have f quarter, it means we're substituting x with 1 over 4. So 2, 1 over 4 plus 1 over 2, 1 over 4 minus 1. And that is going to give us 1,5 for the numerator and minus 0,5, because this is going to be half minus 1 minus 0,5, and that will be 1,5 over minus 0,5. That's going to give us minus 3. So this is like us saying g minus 3. And for g minus 3, we're just substituting minus 3 for x there. So it's 3 minus 3 plus 2. And this will give us minus 9 plus 2, which will give us minus 7. So we're now going to solve f of x is equal to minus 7. So write out 2x plus 1 over 2x minus 1 is equal to minus 7, like that. And cross multiplying, you get 2x plus 1 is equal to minus 14x plus 7. And grouping like terms, we get 16x is equal to 7 minus 1, 6. And therefore our x will be 6 over 16. And we can simplify it by dividing by 2 to get 3 over 8. And that will be our answer. And for number 6, says the diagram shows a metal plate OABCDEF consisting of sectors of 2 circles, each with center O, and the radii of sectors AOB and EOF are r centimeters, and the radius of the sector COD is 2r centimeters. Angle AOB is equal to angle EOF, which is equal to theta radians, and angle COD is 2 theta radians. It is given that the perimeter of the plate is 14 centimeters and the area of the plate is 10 square centimeters. So it's given that r is greater than 1.5 and theta is less than 3/4. Find the values of r and theta. So we're going to try and make equations using the given information. We're told that the perimeter of the plate, which is the distance right around this plate, is 14, and the area, which is area of this plus area of that plus area of that, is 10. But before we do that, let's just make sure we have all the lengths that we need. So for perimeter, we need this one, arc length AB, and for that we're just going to say r theta. The radius is r and the angle is theta. And for this part, since CO is 2r and OB is r, this will also be r. 2r minus r will get r for that part. And for CD, arc length CD, we're going to use r theta, but our r is 2r and our theta is 2 theta, like this, right? And this is r, this r theta, and this is obviously r. So we're just going to write perimeter is equal to r plus r theta plus r plus 4r theta plus r theta plus r. And simplifying this, we have r here, and the last one here, so it's 4r. Then you have r theta plus 4r theta, which gives us 5r theta, plus this r theta right here. So 5 plus 1, the 6, plus 6r theta, and we're told this is equal to 14. So if we factor out r, we get 4 plus 6 theta being equal to 14. I think this will be our first equation. And for the second one, we are now using the area. We're going to get area of A, which is equal to area of B. So we're just going to get area of this and multiply it by 2. Then we get this area, and adding the 2 should give us 10. So for this, we know it's half r squared theta, and multiplying it by 2, we get r squared theta. So then we write area is equal to r squared theta, and that is for a and b. And for this one, we're going to say r squared, but our radius is 2r squared, and our theta is 2 theta, like that. So that will be 4r squared. That will be 4r squared times 2 theta, which is 8r squared theta. So plus 8r squared theta should give us 10, like that. And factoring out r squared, so this will be 9r squared, because it's r squared theta plus 8r squared theta. So 9r squared theta is equal to 10. Now we can solve these simultaneously by saying theta here is equal to 10 over 9r squared if we try and make it the subject. But wait, this got to be r squared theta because we multiplied our half r squared theta by 2. So for this one, it's supposed to be half r squared theta. So this has to be divided by 2. So instead of getting 8, we should be getting 4. And adding those 2 should be giving us 5 r squared theta, like that. And so dividing by 5 on both sides, we get r squared theta to be 2. And if we make theta the subject, now we get theta to be 2 over r squared. And we can substitute this for theta into the first equation. So r 4 plus 6 2 over r squared should give us 14. So this will be r 4 plus 12 over r squared is equal to 14. Now 4r plus 12 over r will be equal to 14. And to clear that r in the denominator, we're just going to multiply everything by r. That is going to give us 4r squared plus 12 is equal to 14r. And we're just going to rearrange that and get a quadratic equation saying 4r squared minus 14r plus 12 is equal to 0. And we're going to use the quadratic formula to solve this. So r will be equal to 14 plus or minus root of 14 squared minus 4 our a and our c all over 2a, which is 4. And that gives us 14 plus root of minus 4 over 2, 4. And that is giving us r to be 2, or r to be 3 over 2. But if you remember, in the question I told r is greater than 3 over 2. So we're just going to take r to be 2. And having 2 as our value for r, and knowing that theta is equal to 2 over r squared, just going to say theta is equal to 2 over r squared. Therefore, 2 over 2 squared, which is 4. The theta will be equal to half. And theta is less than 3/4. So theta equals half makes sense, since half is less than 3/4. Just by doing that, you get 6 marks for number 6. And now for number 7, it says by expressing minus 2x squared plus 8x plus 11 in the form minus a x minus b squared plus c, where a and b are positive integers, meaning they are positive numbers, find the coordinates of the vertex of the graph with that equation. So we are just going to write this in its expanded form. We are going to write that in its completed square form. And for that, we factor out minus 2 first. So we get x squared minus 4x, then minus 11 over 2, like that. And we complete the square for this. So with our minus 2 square brackets, x minus 2 squared minus 11 over 2 minus this squared, which is 4. Then we close bracket. So this will be minus 2x minus 2 squared, then minus, this should be minus 5,5 minus 4, that's minus 9,5, which is minus 19 over 2. Now multiplying everything by minus 2, get minus 2x minus 2 squared plus 19, like this. And now if we have y equals this, we know the coordinates of the vertex will be minus this and this. So minus that is 2 and this 19. This will be the coordinates. These will be the coordinates of the vertex. And for part B, it says the diagram shows part of a curve with equation y equals minus 2x squared plus 8x plus 11, which is this one that we're just dealing with, and the line with equation y equals 8x plus 9. Then it says find the area of the shaded region. So for this area of the shaded region, we're going to use integration. So we're going to need limits for integration, and the limits that we're going to use are the x coordinates of the points of intersection of the line and the curve. So we're going to need those two x coordinates, and we're going to say integral of the curve minus integral of the line. Since the line is below the curve, we're going to say integral of the curve minus integral of the line. Then we apply those limits. But first, to get those limits, we need to equate these two. Since at these 2 points, the line and the curve share coordinates, so we can say y equals y, and therefore 8x plus 9 is equal to minus 2x squared plus 8x plus 11, like that. So we can take everything to the left hand side to get 2x squared. Then these will cancel out. 9 minus 11 will be minus 2, and that will give us 0. And 2x squared will be equal to 2, giving us x squared to be equal to 1 and x to be the square root of that, which is plus or minus 1, meaning this will be minus 1 and this will be 1. So those are the limits that we're going to be using. And integrating now, we said we're going to say integral of the curve minus integral of the line, because the line is below the curve. We're going to do that with respect to x, so minus 2x squared plus 8x plus 11. Then I'm going to say minus dx with respect to x minus the integral of 8x plus 9 dx from 1 to minus 1, 1 to minus 1, like that. And integrating now, we know we just say minus 2x and we add 1 to the power of x there, becomes x to the power 3, and we divide by the new power, plus 8x, adding 1 to the power, it becomes x squared over the new power, which is 2, plus our 11x, like that. When we integrate constant, we just add the variable we're dealing with, and we're going to subtract 8x squared plus 9x, like that. And since we're dealing with the same limits, we can combine it like this. This is going to give us minus 2/3 x to the power 3 plus 4x squared plus 11x minus 8x. This is 8x squared, it should be over 2 because we're dividing by the new power, and this should be 4x squared minus 9x. So after this we apply our limits. So substituting 1 first, we get minus 2/3, and that's times 1. So plus 4 plus 11 minus 4 minus 9. That is giving us 1/3. We're going to subtract what we get after substituting minus 1. So substituting minus 1, there we get 2/3 is now positive. Then plus 4 minus 11. Then minus 4 plus 9. And that will be minus 1/3, like this. And this is to give us 2 2/3 square units to be our area. And get our 5 marks for number 7. Now for number 8, says the equation of a circle is x squared plus y squared plus px plus 2y plus q is equal to 0. This is the expanded form of the equation of the circle, which is usually given like this. But as you can see, it's expanded there. So it says where p and q are constants, p and q are just numbers. And for part A, it says express the equation in that form, where a is to be given in terms of p and r squared is to be given in terms of p and q. And since a and b are the coordinates of the center, we're just going to try and get the coordinates of the center from these, because we know our coefficient of x there, we can refer to it as 2g, and the coefficient of y, we can refer to it as 2f. And we know our center will be minus g minus f. So we can say 2g is equal to p. So our g will be equal to p over 2. And we say 2f is equal to 2, the coefficient of y, and our f will be equal to 1. So for the center, it will be minus p over 2 and minus 1. These will be the coordinates of the center. And so writing it into the equation of a circle, they have negatives. So they're going to be x plus p over 2 squared, then plus y plus 1 squared is equal to r squared. Right? And now to get r, we're going to use the formula r is equal to square root of the coefficient of x, which is p there, over 2 squared, plus the coefficient of y over 2, which is just 2 over 2, 1. If you square it, we get, so just write 1 squared minus this number right here, which is q. And that gives us a root of p squared over 4 plus 1 minus q. But we're required to write it as r squared, so it's like squaring both sides, and we're just going to get rid of the square root sign. So we're going to just write this is equal to p squared over 4 plus 1 minus q. So we write this is equal to this, and that should be it for part A. And for part B, says the line with equation x plus 2y is equals to 10 is the tangent to the circle at point A, which is 4, 3. B part 1 is saying find the equation of the normal to the circle at point A. We have an equation of a tangent, and we know that there's a relationship between gradients of lines that are perpendicular, because a tangent and normal to the tangent meet at 90 degrees. So if we have gradient of this one and gradient of this one, multiplying these two should give us -1. So this is telling us that we can get the gradient of the normal from the gradient of the tangent, like that. And to get the gradient of the tangent, we're just going to rearrange and write that in the form y equals mx plus c. So making y the subject, 2y is equal to minus x plus 10, and dividing by 2, y is equal to minus x over 2 plus 5, because we divide by 2 throughout, and therefore our m will be minus half, and that will be the gradient. So if our m, which we can say m1, is that, our m2 should be negative reciprocal of this, so that we get -1 if you multiply. So the reciprocal of that will be minus 2 over 1, and I said negative reciprocal, so we get it to be 2. So 2 will be equal to our m2, which is the gradient of the normal. And with this gradient of normal and a point on the normal, which is our a, 4, 3, we can get the equation of the normal using y minus y1 is equal to mx minus x1. And so y minus 3 is equal to 2x minus 4, the x coordinate there. Taking everything to the right hand side except y, we say y is equal to 2x minus 8 plus 3, which gives us y being equal to 2x minus 5 as the equation of the normal to the circle at point A. Then for B part 2, saying find the values of P and Q for 5 marks. So we're now being asked to find the values of P and Q. And we're going to use the equation that we wrote in part A in conjunction with these two equations. And we're going to see if they can give us P and Q there. So from B part 1, we were asked to find the equation of the normal to the circle at point A, and we got it to be y equals 2x minus 5. So we're going to use that this way, since every normal to a circle passes through the center. Every line that meets the circle at 90 degrees passes through the center. So we're going to use our coordinate of the center, which is minus p over 2 and minus 1, and this equation that we got, y equals 2x minus 5. So we have y equals 2x minus 5 is the equation of normal, and we're saying all normals to a circle pass through the center. They pass through the center. Therefore, the coordinates of the center are minus p over 2 and minus 1. Let me just confirm. Yes. So if this line passes through this point, then we can substitute these two into the equation to say minus 1 is equal to 2. In place of x, we put minus p over 2, then minus 5. And this should give us our p value. So minus 1 equals minus p minus 5. And 4 will be equal to minus p. So minus 4 will be p. Our p is equal to minus 4. So now we're just left with the q. So we're going to use this equation the one that says x plus p over 2 squared plus y plus 1 squared is equal to, said that is equal to p squared over 4 plus 1 minus q. P squared over 4 plus 1 minus q. And we're going to substitute the value of p first. So we'll get x plus, that's minus 4 over 2, so that will be x minus 2 squared plus y plus 1, like that, squared being equal to 4 squared, that's 16 over 4, which is 4 plus 1 minus q, like this. And now with this, you can see we have x, y, and q. And these x and y values we can get from any point on the circle. I think we're given a point on the circle. A is on the circle because we're told it's the tangent to the circle at point A. So meaning this line touches the circle at point A. So point A is on the circle. We're just going to substitute 3 and 4 for x and y there. So A is 4, 3. So substituting that in there, we're going to say 4 minus 2 squared plus 3 plus 1 squared is equal to 4 plus 1 minus q. And this will be 4 plus 16 equals to 5 minus q. And q will be equal to 5 minus 16 minus 4. 5 minus 16, that's minus 11 minus 4. Q will be equal to minus 15. And you get your 5 marks. And for number 9, you're saying the equation of a curve is that, and the equation of a line is y equals kx plus p, where k and p are constants, with k taking values from 0 through to 1, but the values not being equal to 0 or 1. And part A is saying it is given that one of the points of intersection of the curve and the line has coordinates 5 over 2 and half. And it says find the values of k and p and find the coordinates of the other points of intersection. And so for given that point, the coordinates of that other point of intersection, we're going to try and substitute those values into these equations. So for y equals kx plus p, I'm going to say y is half when our x is 5 over 2. So this should be half is equal to 5 over 2k plus p. And clearing off those fractions, we multiply by 2. So we get 1 is equal to 5k plus 2p, like this. And there's really not much that we can do with this for now, so we can label it 1. It's our first equation. Then we're going to substitute it into this equation as well, to say when y is half, we have half k squared. Then for x, it's 5 over 2 being squared minus 2k, or x 5 over 2 plus 2, like that. Now simplifying this, we get half is equal to 5 over 2, the 2,5 squared is giving us 25 over 4. So 25 over 4 times half, that's 28, or 25 over 8 k squared And for that, we have minus 5k plus 2, like this. And we can clear that fraction by multiplying everything by 8. So we get 4 is equal to 25k squared minus 40k plus 16. And we can solve this quadratic equation here to get the value of k. So 25k squared minus 40k plus 16 minus 4, that's 12, is equal to 0. And to get k, we can use the quadratic formula. So this will be 40 plus or minus root of 40 squared minus 4a and our c, all over 2a, like that. And you get 40 plus root of 40 squared minus 425, 12 over 225. That is giving us k to be 1 and a fifth, or for the other value where we take the minus, we're getting k to be 2 over 5. Now we have two values of k, but we're given a range. K should be between 0 and 1, and we can see that this is greater than 1, so we're just going to take k being equal to 2 over 5. And with that value of k, we can get the value of p by substituting it into that. So 1 is equal to 5, then we substitute k with 2 over 5, and like this, and we get 1 is equal to 2 plus 2p, and this will give us minus 1 being equal to 2p, and minus 1 over 2 should be p. So write it like minus 1 over 2, like that, is equal to p, and that should give us our 7 marks in full. But it says, and find the coordinates of the other point of intersection, and to get the coordinates of the other point of intersection, we're going to substitute these values that we got, the value of k and the value of p, into the original equations. The equation of the line y equals kx plus p, y equals kx plus p, so it'll be y is equal to 2 over 5x minus a half. And the other one, substituting k there, we have y being equal to a half this squared x squared minus 2k is 2 over 5 x plus 2. So that gives us 2 over 5 squared, that's 4 over 25. And if we are saying half of 4 over 25, getting 4 over 50, so y is equal to 4 over 50 x squared, then minus 4 over 5x plus 2. So I'm just going to write it down here. Y equals 4 over 50 x squared, y is equal to 4 over 50 x squared minus 4 over 5x minus 4 over 5x plus 2, like that. And we're going to try and equate these two. Since they are points of intersection, they share the same y coordinate, so at those points y is equal to y. So we can say 2 over 5x minus half is equal to 4 over 50 x squared minus 4 over 5x plus 2, like that. And to simplify this, we're going to try and multiply everything by 50. So that gives us, this would be 10 times 2, 20x minus 25 is equal to 4x squared minus 40x plus 50 times 2, that's 100. Now from here we get 4x squared minus 40 minus 20 minus 60x, then plus 125 is equal to 0. Using our quadratic formula, we get x to be 60 plus or minus root of 60 squared minus 4ac over 2a, which is 2 and 4. And this should give us two x values, which we're going to substitute into one of those equations. So 60 plus root of 60 squared minus 4 ac over 2a is giving me 25 over 2, or the other value, which is 2.5, 5 over 2. So these are the x values that we have, but for the coordinate that we're given, we already have 5 over 2. We already have this. So this is the x coordinate of the other point of intersection, and to get the corresponding y coordinate, we just substitute that back into one of these two equations. So using y equals 2 over 5x minus half, you say 2 over 5, then you say our x is 25 over 2 and minus half, like that, and we get our y to be 4.5. So this will be the coordinate. You can write it as 25 over 2 and 4.5, that's your 9 over 2. That will be the coordinate of the other point of intersection. Alright, and part B, saying it is given instead that the line and the curve do not intersect. Then it says find the values of P, find the possible value, find the set of possible values of P. And for that, we use this, because we would first equate them like what we did here and get to this point. But from here, we would refer to the discriminant. So just going to write that down here, 4x squared minus 60x plus 125. Now with this, we refer to the discriminant, which is our b squared minus 4ac, and we know our b is minus 60, so we're saying minus 60 squared minus 4, our a is 4, and our c is 125. But as you can see, this is going to give us a number, and yet we need a set of values of P, and that is telling us that we need to use something in terms of P. So let's try and use these instead, these original equations that we're given, and equate them. So the curve is y is equal to half k squared x squared minus 2kx plus 2, and the line is y equals kx plus p. Y is equal to kx plus p. Now we can just equate these two and then use the discriminant, because we know that if the discriminant is less than 0, these two do not meet. So to get that, we're going to say half k squared x squared minus 2kx plus 2 is equal to kx plus p, like that. And grouping like terms, we get half k squared x squared minus 2kx minus kx plus 2 minus p, and this gives us half k squared x squared minus 3kx plus 2 minus p, like that. So for this will be our a, this will be our b, and this will be our c. So when you say b squared, we're saying minus 3k squared minus 4, our a is half k squared, and our c is minus 2 minus p, like that. And so this is giving us 9k squared, and this is minus 2k squared minus 2 minus p, and so we get 9k squared, right? This is positive 2, so you get minus 4k squared plus 2k squared p, like that. And this comes down to 5k squared plus 2k squared p, and this should be less than 0 because we're told already that they do not intersect, so the discriminant should be less than 0. But we're just going to ignore this for a moment and factor out k squared. So k squared, we have 5 plus 2p being equal to 0. So then you say k squared is equal to 0, or 5 plus 2p is equal to 0. Then we get p to be minus 5 over 2. Now we take this sign back into consideration to replace this equal sign, so p is less than minus 5 over 2. And so that represents a set of values of p, given that the line and the curve do not intersect. Right, and you have 3 marks for that. For number 10, it says the function f with domain x is greater than 0 is such that f of x is equal to 8 bracket 2x minus 3 to the power a third and 10x to the power 2/3. It is given that the curve with the equation y equals f of x. So this is f prime of x, not f of x, and it is given that the curve with equation y equals f of x passes through the point 1, 0, and says find the equation of the normal to the curve at that point. So we're first going to get the gradient of the curve at that point. Since this is f prime of x, this will serve as our dy dx. So if we substitute 1 in there, we'll get the gradient of the curve at that, and from there we'll get the gradient of the normal, and using this we get its equation. So substituting 1 in there, we get 8 and 2 minus 3, that's minus 1 to the power third, just writing that down, minus 10 minus 10 x, which is 1 to the power 2/3, you get 1. So you're getting minus 18. So m is minus 18. Now the gradient of the normal is the negative reciprocal. So the reciprocal of that is 1 over minus 18. But if we're saying the negative reciprocal, it's like we're multiplying that by a minus, and it will give us 1 over 18 to be the gradient of the normal. And using that and 1, 0 there, we have y minus y1, x minus x1. So y minus 0 should give us 1 over 18 x minus 1. Y should be equal to 1 over 18 x minus 1 over 18. And that will be the equation of the normal. And for part B, it says find x for 4 marks. And so to find x, we are going to use integration. Remember, questions that require you to get the equation of a curve given dy dx is the same principle here. So we're going to integrate this. Then after that, integrating that, we're going to get a constant, and to get rid of that constant, we're going to substitute this point. And so to integrate that, we say 8 2x minus 3, and we add 1 to the power, it becomes 1 and a third, which is 4 over 3, and we divide by the new power and multiply by the derivative of the bracket. If we differentiate 2x minus 3, we get 2, so we multiply by 2 there. Then say minus 10x, add 1 to that power, so 2/3 plus 1 is 1 and 2/3, which is your 5 over 3, and you divide by the new power and you add a constant like that. And so simplifying that, 8 divided by 8 over 3, that is giving us 3 there. So it's 3 2x minus 3 to the power 4 over 3. Then this is minus 30 over 5, which is minus 6x to the power 5 over 3 plus c, and that will be f of x. But to get the constant c, we're just going to substitute 1 0. Say f of x is equal to 0 when x is equal to 1. So substituting 1, 3, 2 minus 1, that's your minus 1. Then minus 6 minus 1 to the power of 5 over 3, like that. We get minus 3 plus c, and so our c will be 3. Now after that, we just write our f of x is equal to 3 2x minus 3 to the power 4 over 3 minus 6 x to the power 5 over 3 plus 3, and that will be our f of x for 4 marks. And for part C, which is the last question, says it is given that the equation for f prime of x is equal to 0 can be expressed in that form. Determine, making a reasoning clear, whether f is an increasing, a decreasing, or neither. So we know f can only be an increasing function when the expression for f prime of x is telling us that it's always positive, and it's a decreasing when it's always negative. We're not worried about this one for now. And for us to make those deductions, we are going to complete the square. Just going to complete the square, and completing the square there, we start off by factoring out 125. So get x squared minus 128 over 125x plus 192 over 125, like that. Completing the square for this, we get our x minus 125 times 2, that's 150, so 128 over 250 x, oops, there's no x there, squared plus 192 over 125 minus this squared, so 128 over 250 squared is giving us 0.262144, and all this is being multiplied by 125, so get 125 x minus 128 over 250, like this, and put squared. Squared like that, and for that first need to say 192 over 125 minus 0.262 144, like that. You're getting plus 1,273,856. And as you can see, for any value of x that we input here, this will always be positive, and to that positive number that we get, we are adding this part as well, meaning this whole thing is always positive. So we just go ahead and write that f prime of x is always positive because x minus 128 over 250 squared is always positive for any value of x. Therefore, after that, you say it is an increasing function, like that, and you get your final 3 marks. That brings us to the end of this paper. I hope you are following through and you understood